Okay, here we go. So normally we do this as a bell quiz, but where we did test corrections, let's just go over it because this is going to be what we're doing today, inverse trig functions. So let's remember how to find the inverse of just regular old functions. We switch x and y. You wouldn't need to take notes right here. So solve for y, correct? This is how we find inverses. So we'd have x plus 3 equals 2y squared. Then we would divide by 2. We would have x plus 3 divided by 2 equals y squared. And then we would square root it. And what can we not forget? Okay, I like that. We have to not forget that, yeah, we probably should rationalize this. I like that idea. And also not forget plus or minus, because we have a full quadratic, so we need the top and bottom square root, right? Okay, so then even though it makes it not a function, so then we would rationalize, and we would get plus or minus the square root of x plus 3 times 2, correct? All over 2. Was everybody able to see how I rationalized that in my head, kind of? Okay, cool. So how would I find, this is what's more important, how would I find inverse of xy points? Yeah, so negative 2, 3, and then negative 5, 4, and then negative 1, 5. Keeping in mind on the ACT, they would then reorder it from least to greatest. So not to throw you off, because they won't have it in that order. Does that make sense? Least to greatest for x. Like, we're not going to change the y's, because I know a lot of you misunderstood that. And on the test, you relined up. That is an xy point. So the only thing that would change is you'd say negative 5, 4 should come first. Negative 2, 3. Negative 1, 5. Okay, sweet. Moving on. So we're going to now just jump right into it. We're going to be graphing and talking about inverse trig for sine. So if we were given y is equal to sine of x, if I said to you find the inverse, you would switch x and y. You'd have x is equal to sine of y, and then you'd say, I need to get y alone. It's trapped inside sine. I'd sine inverse both sides. And boom, that's how we get this function, y equals, oh, that's sine. That's how we get this, the sine inverse function. Now, this is the easiest way to graph sine inverse is to look at the original xy points of sine and then just switch them. So this is going to help us graph sine inverse. So I am going to hurry and quickly graph sine. Now, notice for sine, I've graphed one cycle. 0, we go around the unit circle. 0, pi halves, pi, 3 pi halves, and then 2 pi. And then I did 0, max, 0, min, 0. Then I did just go one step further, one below. So negative pi halves, and then it would be negative 1. So let's graph this. You don't need to graph this, guys. You've already graphed this. Yeah, we're going to have to restrict it. So Josh was already putting 2 and 2 together. The inverse sine would not be a function. So we're going to have to restrict it down to make it a function for us. So what the heck? 1, 2, 3, 4, 5. I have too many tick marks. So that's really 2 pi right there. So you guys already know how to graph this. This is just going to help us see what's happening here. Okay, and then I went back negative pi halves. Here we go. So I would say, okay, sine is 0 max, 0 min, 0. And then does everybody see how I know I'd be going down to continue the pattern? So right here, I'd be here. So it looks something like this, and it continues. Okay, so let's switch these xy points. So we would have negative 1, negative pi halves. We would then have 0, 0 still. We would then have 1 pi halves. We would then have 0 pi. We would then have negative 1, 3 pi halves. And then 0, 2 pi. So notice now my new x values, if you notice, are bouncing between 0, negative 1, and 1, aren't they? My new x values, everybody? So if I was to graph this, I would go, okay, so negative 1, here's 0 and 1. And then now look at my y-axis. My y-axis is now the pi's, correct? We're kind of tilting our head like this and looking like this, aren't we? So down here would be negative pi halves, 0, pi halves. I'm trying to draw this a little bit to scale. Pi, 3 pi halves, and then 2 pi. So let's start graphing these points. So plotting the points, negative 1, negative pi halves, down and down, over 0, 0. And guess what? I'm not going to actually have you on the test reproduce this graph. The graph helps you see why we have to restrict and what's going on with sine inverse. So I won't ask you to actually graph sine inverse. Over 1 up pi. Okay, so let's look at what's happened so far. Isn't it coming up, coming up? And then now look, over 0 up pi. Well, okay. Now am I circling back? Isn't that becoming a problem, an issue now? It hadn't been an issue up to here because it had passed the vertical line test, but now we're circling back on ourselves. which would make it not a function. So we got to stop because this is bad news. We need to keep it a function. So instead of continuing this, we're going to stop and say, okay, we better stop and only graph this up to where it was a function. So it stopped being a function after pi halves. Does everybody see? So we only graph sine inverse on this interval from -1 to 1, and then from negative pi halves up to pi halves. So that brings me, here's the bigger picture of this. So what I want you to notice is our domain for sine inverse is between -1 and 1. So could I plug in -2 into sine inverse? No, because that's not an input. -2 is outside of the input. Does that make sense? You can't plug in -2. Do you see there's not a function over here? Right? Because the only available input is between -1 and 1. There's our domain. Our range, which means output or answers, how they come out, have to be on this interval from negative pi halves to pi halves. Our only answers for sine inverse are going to be between negative pi halves and pi halves. And then including negative pi halves and pi halves, because that dot was all good to go. So I want you to look right here. Pi halves is up here. Right here's pi halves. And then down here is negative pi halves, which is the same thing as 3 pi halves, but we can't call it 3 pi halves. Because isn't 3 pi halves up here? Isn't that where we stopped going up there, correct? Because it's not a function up there. So we would have to, instead of calling this quadrant 4, we're going to call it negative quadrant 1. So if this is 30 degrees, then this will be negative 30 degrees. Our outputs have to be negative. And then negative 45 degrees, negative 60 degrees, and then negative 90 degrees. And then our positives as well, okay? So if I said to you, find the inverse sine of 2, you'd say I'm inputting 2. We can't put in 2 because that's out here and there's not a function, so you can't find that. And if you tried to type that into your calculator, it would say error. Sine inverse of 2. Hit second sine of 2 and it will say error. So now this is what we will do. It says, for the inverse sine, we will always be given our answers on an interval from negative pi halves to pi halves. So if I said to you, find the sine inverse of negative root 2 over 2, you would locate that in quadrant 1 or negative quadrant 1. So that would be right here, correct? Sine is y. So then the angle whose sine value is that would be negative pi fourths or negative 45 degrees. Our answer would be negative pi fourths or negative 45 degrees. So some of you are probably saying, well, wait, I'm a little bit confused. So let me explain better. So this is really what you're looking for when it says sine inverse. Now, everybody listen. Sine inverse is one way of writing it. Arc sine is the exact same thing as sine inverse. It's just a different way of writing it. So they mean the same thing. Not to be mistaken with cosecant x. Remember, we graphed cosecant, right? We graphed cosecant. This is totally different. Sine inverse, we just graphed sine inverse. It looks nothing like cosecant. So that is not what this is. So everybody, sine inverse and arc sine mean the same thing. So I literally say this to myself every time I read sine inverse. What sine inverse or arc sine is saying is what angle whose sine value or whose y value will be that value. So what angle has that y value, basically? What angle has that y value? And then you say this angle, 45 degrees. Does that kind of make sense? So look right here. It's going backwards of this. So if I said find the sine of pi fourths, we already know how to do that. We'd locate pi fourths, wouldn't we? Sine is the y value. So we would say root 2 over 2. What sine inverse is doing is going backwards. It says, what angle has a y value of root 2 over 2? So you'd say, well, there's root 2 over 2, isn't it? Root 2 over 2, everybody? So what angle is that? Pi fourths. Or we could say 45 degrees. Does everybody understand? Yeah. Okay. So I'm going to go back to here. Remember, our outputs were only on this interval from here to here. So all of our answers have to come out on that interval. So could I have said on this one, because a lot of people say, well, also, right here is root 2 over 2 for sine. But do you see how 3 pi fourths is not on the interval for outputs for sine? Because remember, sine's outputs only happen right here. So we can't do that answer. Okay, cool. Here we go. There is literally one specific answer for all these. So let's start answering this. We have an angle whose sine is negative 1/2. You're going to get more out of this if you're just actually watching at this point, I think. We have an angle whose sine is negative 1/2. I've even highlighted it for you. So where's the y value 1/2? it's negative 1/2, so it's not that, it's right here, isn't it? Like Adam's saying. So what would my answer be? We can't say 11 pi 6 though. Good point, because that would be not in our available outputs, but yes, in that same spot, just negative. Yes, negative pi 6. Thank you, Joseph. Negative pi 6, or we could call it negative 30 degrees. Awesome. Either answer works. Your textbook will say to you, give your answers in radians or give your answers in degrees. So find the angle whose sine value is √3/2. So it's right there. Really easy. It's 60 degrees or pi thirds. Pretty easy stuff, right? Now everybody think, here's my graph with sine inverse. Find the angle whose sine value, whose y value is 2. Can we input 2? No, we talked about that. Only put input between -1 and 1. So right here is -0.5. Do you see how that's okay? Because that's about right there. And √3/2 is about 0.86. So do you see how that's okay? Because that's right here. But 2 is over here, so we'd say can't do it. I don't know if it would necessarily be I'm trying to think. Because that's just where it's not a function, you know? I don't know if we would call it undefined. We can't find that value. So maybe it would be considered undefined in a sense. I'll get back to you while I think about that. Hey, we have an angle whose sine value is negative √3/2. See if you can answer it. So it's not negative 300 though, right? Because that would be like over here. Yeah, negative 60 degrees. Is everybody good? Or negative pi thirds. Okay, good? And then now careful though, let's go to this one. We have an angle whose sine value, whose y value is -1. Gotta be on this interval. Yes, negative 90 degrees or negative pi halves. We could not say those 3 pi halves just because that's not in our available output. Is anyone confused? Can I answer any questions, clarifications? So it's happening right there, but once again, this is not quadrant 4, it's negative quadrant 1. Yes. -1. That makes sense. Because we're looking at y value. Oh, so if you'll keep that in mind, like, you see how that would be okay? We are bouncing to -1 on our y value. Okay. Yeah. Great question. That is a great question. So we're only bouncing between -1 on y. That is a really great question. I'm glad you actually asked that. Okay, cool. So now here is the difference though. Look right here. This one is this is not asking inverse sine. So if I said to you, sine of theta is equal to negative √3/2. This does not say inverse sine. So I have to remind you of something. If I was to graph sine, wouldn't that go on forever? Isn't our domain all real numbers? And isn't there going to be lots of times, as many times as I want to go around the unit circle, where the y value will be negative √3/2? So where does that happen? Right there and right there. So I have two answers on the first way around the unit circle. My answer here would be 4 pi thirds, and then the next answer would be 5 pi thirds. But then we just said we can continue around this unit circle again and again and again, can't we? And we can go backwards too. So anytime it lands right there or there. So wouldn't it be plus 2 pi plus or minus, right? 2 pi as many times as we want to add the circle. Won't that always be a solution anytime it lands there? Okay, cool. So these are do you see the difference in the problem? Right here it said, what is the angle where the sine is this? That happens a limited number of times, there and there. Where here, we'd have to say, oh, sine inverse has restrictions, because sine inverse only looks like this. Does that make sense? The difference. Okay, cool. All right, let's see if you could do this top one. We have an angle whose sine is 1/2, just making sure we're good. Okay, now this one's interesting. It always gets people. Guess what people do here? They say, I have an angle whose sine is pi 6. They go to pi 6, and then they go 1/2. They just treated it like we said sine of pi 6. But that's not what we asked for. So you have to remember, this one tricks people. What is this asking? It says we have an angle whose y value, because that's the sine, is The y value is pi 6. Well, does that even happen on the unit circle where the y value is pi 6? Not in an exact place, correct? That's a decimal, so let's make sure we can put it in. First of all, we got to check. Can we plug in pi 6? Is that an input that we can put in? So what is the decimal of pi 6? Is it? So 0.52. So you're making a good point. It's slightly greater than halfway, correct? So right here, we can put that in, correct? And now look, my output is going to be some radian, right? Some radian. But we don't know what radian because it's not on the unit circle. So this would be an appropriate time to type it into your calculator since you can't do it by unit circle. So you would just type in sine inverse, type in your calculator, sine inverse, make sure it's in radian mode, because look, I'm inputting in radian mode, pi divided by 6, and what do we get? What decimal? 0.55106. Perfect. So that is just like, and look, right here we were giving a distance, right? Technically, it's just we're able to give exact answers because it was on the unit circle. Where here we're having to give the decimal radian. Okay, cool. So it is distance, yes. All right, here we go. Let's graph inverse cosine. Here's normal old cosine over 1, 2, 3, 4, 2 pi, pi. You get the picture here. So graphing cosine is max, 0, min, 0, max. There's cosine. So to graph cosine inverse, I'd switch x and y. Okay, I'm going to start plotting. So notice, once again, my x values for cosine inverse are between 1, 0, and -1. So I'm going to go -1, 0, 1. And then my outputs are, once again, looks like 0 up to 2 pi. So 0, pi halves. Okay, I'm going to start plotting points here. So over 1, up 0. Boom. There's my first point. Over 0, up pi halves. Awesome. So we've gone like this. Boom. And then over -1 up to pi. So then we're coming up. And then we're going over 0 up 3 pi halves. Now, aren't I now circling back again and we're in a problem area, correct? So this is like sine inverse. We got to stop because now we're creating a problem after this. So we were only able to graph cosine inverse from 0 up to pi. And that was the first time we had a problem. Does everybody see? Okay. So here is the graph for cosine, just bigger. So cosine's domain will be from -1 to 1. And then its range, we started at 0 and then went up to pi before we had any problems. So that's why the range on cosine inverse is from 0 to pi. So now the outputs for cosine inverse are unlike sine. Remember, sines were right here. Ding, 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 ding. But cosines are actually quadrant 1 and 2. The outputs are quadrant 1 and 2 because now our outputs are between 0 and pi. Now, I always have people ask me, so if you think back, I'm going to scroll back to sine real quick. So notice cosine is from 0 up to pi, correct? I always have people ask, well, why did you graph sine? Why did you graph sine of negative pi halves? Why didn't you just start at 0? And that is a really valid question. So why didn't we just start at 0? Because here's why. So let's say we started at 0, then this would have circled back down. Do you see how then it creates a problem? Because if we were to just start at 0, we would then, and it's going to start circling back up. Do you see how on that interval, if we started at 0, we wouldn't even be able to graph a full cycle here. So what we're doing is we're graphing the first full cycle without a problem. Does that make sense? So that's why we have to start down at negative pi halves for sine. With cosine, though, there wasn't a problem starting at 0 up to further up. Does that make sense? A full cycle. Okay, cool. All right, here we go. Let's answer the questions now. Same idea. It's just we got to remember the outputs for cosine are quadrant 1 and 2. We have an angle whose cosine is root 2 over 2. So locate cosine's x. Root 2 over 2 does not happen there. So my angle is pi fourths or 45 degrees. True? We have an angle whose cosine is negative root 2 over 2. That would be there. So you'd say either 3 pi fourths or, yep, 135. Does everybody see how this is working? Same as sine. It's just our outputs are now quadrant 1 and 2. Correct. Quadrant 3 will never get love. Quadrant 4 actually does, right? Technically, in a sense. It's negative quadrant 1, which is quadrant 4, but yeah, I get what you're saying. Okay, we have an angle. We have an angle whose cosine is negative 1. Boom. It's pi or 180, isn't it? We have an angle whose cosine is negative 1/2. Isn't that this one? The angle is 2 pi thirds or 120. We're getting the picture here, right? Yes. No, unless, so if it's not on the unit circle, you would use your calculator. As long as you really can put it in. As long as it's an available input. Hey, let's see. Oh, so Eric is asking this question pretty much. We have an angle whose cosine is pi, which means, write this out if you need to. We have an angle whose x value is 3.14. Isn't that what this is saying? Well, look, that's not on our unit circle, is it? X of 3.14. Oh, I guess actually, no x is x, right? This is 3.14, but not x. So this would not be on the unit circle. So the next thing you would check is, we can do this in our calculator if we can truly plug in 3.14. For cosine, can I plug in something larger than 1? No, there's not a function, you see? So with this one, you'd say I can't do it. If you tried in your calculator, it'd be error. Okay, moving on. So here's inverse tangent. We're doing good. Tangent inverse. I'm not going to get into too many gory details here. Here's regular tangent. So remember for regular tangent, we have our first asymptote splitting. Remember for tangent, the first period, a period in tangent is pi, correct? Remember for tangent, our asymptotes are split evenly over the y-axis. So then our asymptotes are at negative pi halves and pi halves. Remember how these worked? 0 amplitude, and tangent was increasing. So I've already switched the xy points and graphed tangent inverse here. Here's tangent inverse. So what I want you to notice for tangent inverse is our domain is actually all real numbers. Where remember for sine and cosine, our domain was -1 to 1, wasn't it? For cosine inverse, sine inverse. But tangent, we can plug in anything in the tangent inverse that we want. However, our answers for tangent inverse are going to be between negative pi halves and pi halves, which is similar to sine. Because that's also the interval of outputs for sine. Now, one thing to note, for sine, it could land on negative pi halves and pi halves, but for tangent inverse, it can't, because that's an asymptote, a value it can't be. So that's why I have parentheses around tangent inverse. So let's answer some tangent inverse problems. So notice I've highlighted once again quadrant 1 and negative quadrant 1 based on the fact that our outputs have to be between those quadrants, and here we go. So it says, oh, but first, we need to be memorizing to make our life way easy what tangent of 30 and tangent of 60 is. What does it simplify to be? So tangent, let's just quickly do tangent, not tangent inverse, tangent of 30. So you say tangent of 30 is my y divided by my x, isn't it? So dividing fractions is easy as pi, flip the second and multiply. So then wouldn't that rationalize to be √3/3? So the tangent at 30 degrees is √3/3. That's what that's going to simplify. What's the tangent at 45? And then what's the tangent at this? Let's do our y divided by x. So I've done that over here. So then times by 2/1, which is √3. Okay, so we know the tangent at 60 is going to always simplify to be √3, correct? Now, here's how I remember it, because it's really easy to forget which one's which. So this is a dumb trick I use. I know it's going to simplify to be √3 or √3/3. So do you see how 30 degrees, the smaller angle, simplifies to be the bigger answer? And the bigger angle, 60 degrees, simplifies to be the smaller answer. Bigger as in there's more to it. It's actually smaller, right? You guys are so technical as honor students. No, you're right. So bigger in like ugliness. That's a stupid trick I use. Okay, here we go. It says you have an angle whose tangent simplifies to be √3/3. What would that be? Nope, it's the smaller one, 30, right, everybody? 30 degrees or pi 6. All right, it says we have an angle whose tangent is negative root 3 over 3. That's the big one, so the smaller angle, so that's negative 30 degrees, correct? Right here? Negative 30 degrees or negative pi 6. Because remember, you have to answer it from negative pi halves to pi halves. We have an angle whose tangent is negative 1. Remember, tangent is y over x. So, which one? What's the answer? That one? So negative 45 degrees or negative pi 4s? You cannot say 7 pi 4s. That's not in the output. We have an angle whose tangent is 0. We have an angle where the y divided by x, isn't that what tangent is 0. What angle is that? 0 degrees or 0 radians, right? Isn't that where it happens? Is that 0? Can I say 2 pi? No, because that would be not in the interval from negative pi half to pi half. Okay, cool. I would take a picture of this right here. Here is the sine inverse graph, the cosine inverse graph, and the tangent inverse graph. So a couple things to note here. Notice for sine, our outputs are the top and bottom, which is the exact same as tangent, top and bottom quadrant. Quadrant 1 and negative quadrant 1. The only difference between sine and tangent is we cannot have down here or up here for tangent, right? And then cosine is the odd man out. That's the top quadrant here. So like everybody was saying, quadrant 3 never gets any love. So cosine's the odd man out. It's the top half. Okay, let's start answering some bigger ones now. Stupid. Okay, so here we go. We're now putting more together. It says, okay, so let's look here. You guys all want to be rezoning back in if you zoned out, because this is where you're going to have a hard time. It says, find the cosine inverse of cosine of 2 pi thirds. That looks like a big scary problem. What you need to be doing is solving from the inside out. So literally, just focus in sections. Say, what is the cosine at 2 pi thirds? Locate 2 pi thirds. Boom, right there. What is the cosine? So rewrite it. You have cosine inverse of negative 1/2. And now you say, okay, I'm going to start my brain thinking over. This is literally saying we have an angle whose cosine is going to be negative 1/2. So what's my answer? 2 pi thirds. Does anyone notice anything? It what? Cosine and a cosine inverse and this one undid each other, didn't it? That doesn't always work though, so don't get too excited. And just go start going on the assignment. You're going to have half of them wrong. Okay? So watch, something interesting happens here. So if you just say, oh, these cancel out, 4 thirds, wrong go, can't do it. Because it's not in the right place. So let's go through it. The cosine at 4 pi thirds. Well, let's look. That's right here, correct? So we're actually doing the cosine inverse of negative 1/2. So you say, I have an angle whose cosine is negative 1/2. So what are you saying, Tanner? No, so now, because now what are we answering? So now we just got to put the correct answer. We have a cosine, an angle whose cosine is negative 1/2. Don't we have to answer up here for this part? Does everybody see? We have to answer up there. So my answer is 2 pi thirds. Mostly radians. Does everybody see? So can anyone put a connection of why did it work up here where it canceled out, but not down here? Can anyone put a connection together? She's putting the connection together. She's thinking advancedly. Well, the first one was up here, and then it was the answer is going to be up here again. So we could just undo those because it is going to work out. Where in this one down here, the answer, we found the cosine, but then the answer can't be, the angle can't be down here. So then we put it back up here. Does that make sense, everybody? Okay, cool. Let's do this one. We have an angle. Are we focusing? There's a lot of connections that are going to be being made here that you're not catching on to. We have an angle whose cosine is negative root 2 over 2. So don't we have to answer only in special spots for cosine? The top, right? So where does that happen? Okay, so we're asking for the cosine of 3 pi fourths, which is negative root 2 over 2. Will that, these ones undo each other. Will that always undo each other or will it not? Wait. Think this way. Will it always undo each other in the correct way? Why do you say yes? Yeah, yeah, you're right. He is completely right. Aren't we going to find the correct angle here on the correct quadrant, in the correct place, I mean, you know? And then where are we going to then find the cosine? And of course it's going to be that. Does that make sense, everybody? So if cosine inverse is inside, it's going to undo each other in the right spot. Okay, let's do a couple more. We have the arc sine, the sine of 3 pi halves. Try that one by yourself. It's always easy to watch me do it. If you're wrong, totally fine. That's why we're learning, you know, to be wrong and figure it out before you go home. So what answer did some of you get? So I heard 3 pi halves. Cool. What other one? Negative pi halves. Any others? Okay. So let's see which one's right. There was a few people talking about the same thing. So let's do this here. We would say the sine of 3 pi halves is negative 1. So now we'd say we have an angle whose sine is negative 1. And you'd say, oh, arc sine has restrictions, right? We have to now answer between pi halves and negative pi halves. So yeah, we're landing there, but we can't put that, can we? It's negative pi halves would be the correct and only correct answer. Does that make sense, everybody? Okay, great. That's good. Yes. No. Okay. What's my answer here? It's negative 5. Didn't we say that you can plug anything into arctangent, can't you? Remember the graph? You can plug anything into arctangent, yep. And then isn't arctangent and tangent going to undo each other? So we get negative 5. Now think about why that makes sense. If we find an angle whose the angle where tangent is negative 5, that is going to be the tangent. We are going to have negative 5 as the tangent. I didn't say that very good. Because we're going to find the correct angle, right? And then when we go backwards, we're going to be back at negative 5. Everybody good? Okay. So up here, try this one. Arc sine, a sine of 5 pi thirds. Try it again. What was the answer here? Negative pi thirds. Was everybody able to get negative pi thirds? Because we can go over it. Or negative 60. Good. Any questions on that? We can go through it if need be. Okay. Now right here, this one tricks people. Careful. We can say most of the time that these just cancel out. However, we do have to check one thing first. Can we even find the inverse cosine of that? That's the first thing we check. If so, they just cancel out. We can find an angle whose x value is 3.14. That's greater than 1, isn't it? So that can't happen. So then not happening here. Nope. Because we can't plug in 3. We can't, remember cosine inverse, we can only plug in values between negative 1 and 1. For cosine inverse. So if I did this, cosine of cosine inverse of 0.23. You could say the answer is 0.23. Because that is an input we can put in. And then they do undo each other. Okay, yes. Yeah, but what do we have to find first? Cosine inverse, correct? We can't calculate the outside and then go inside. We're calculating the cosine inverse of pi, which once again, cosine inverse of pi. Look, right here's cosine. We have an angle whose cosine is 3.14. Can we even plug in 3.14? No, that's outside of cosine's input. You're switching y and x. You're like switching y and x in your head. Because now, look, this, yes, is an available output, not input. You're switching input and output with cosine in your head. You're saying we can plug in pi. Look, there's a pi. That's the output for cosine. That's output. Input, can we plug in pi? This is in, we get something out. Do you get what I'm saying? So you can't plug in in pi is 3.14. You can't plug in pi. That's over here, which would have no function. I thought I found that really. So now this one says, careful, it says find the tangent of the angle whose cosine, if you need to write out what this says to make it not confuse you, we have an angle whose cosine is x, correct? No, I'm about to make a huge error. I'm saying whose x value, well, is this on the unit circle? Then I can't assume it's an x value, everybody, right? That is unit circle only. All those other ones were unit circle. That's why, yeah, unit circle. That's why we were able to do that. So instead on this one, we have to say, oh, no, not x value, not x value. So if it's not on the unit circle, cosine is adjacent over hypotenuse if it's not on the unit circle. So it says we have an angle whose adjacent over hypotenuse is 2/3. Isn't that what cosine is? Is adjacent and hypotenuse. It's not on the unit circle. You can't call it an x value. So we'd say, okay, we have an angle that has a cosine of 2/3. Okay, I can draw that. So we have a right triangle. We have an angle. Its cosine, adjacent, hypotenuse is 2/3. We have an angle whose cosine is 2/3. Do you see how I've drawn that correct? So now this is literally saying find the tangent of this triangle. So tangent is opposite over adjacent. So you'd say push pause, yep, 3 squared minus 2 squared equals question mark squared, 5 equals question mark squared, so square root of 5, right? So you'd say, okay, tangent is opposite over adjacent. So my answer here would be root 5 over 2. So we just can't treat it like a unit circle. If it's not on the unit circle, it's not a radius of 1. We can't call it x. Yes. True. Because you would treat it like a fraction, so you'd have a hypotenuse of 1. Yep, you could put a point. And then arc means sine inverse, which means angle, right? An angle. So this is saying we have an angle whose sine is -3/5. That is not on the unit circle, so we can't call it y. We can call it, though, opposite and hypotenuse, because that is what sine is if it's not on the unit circle. Correct. We couldn't plug that in. Good point. And then if you guys, that is actually a really good point. You could check to make sure that that fraction is actually a decimal between -1 and 1. We could do it. Yeah, we could do it. This means we have an angle. We have an angle whose sine, arc and inverse sine mean the same thing, right? We talked about that. Just writing it 2 different ways. So we have an angle whose sine, sine is opposite and hypotenuse, is -3/5. So -3/5. Opposite should have been here. Good point. So now let's do Pythagorean theorem. Oh, so now it asks us find the cosine of that triangle. So we quickly find that. It's going to come out to be 4. So then you would say, okay, cosine is adjacent over hypotenuse. So my answer is Orpheus. Ooh, I'm glad you guys are bringing up this thought process. So we do have to, when we're drawing this, is this positive or -4? So remember for sine, it's either a triangle over here or down here for arc sine, right? So then we knew that it was definitely -3. So because it's sine, ooh, I'm so glad you asked that. Nobody in all the years I've taught have ever asked that. Because if it would have been cosine, we would have had to do something. No. We've lucked out and it just happened. We've written down the right thing. Yeah. So then from here, we know this must be +4 and then 5. I like it. Okay, cool. Okay, so let's do this one. We have the sine of the angle whose cosine is 3x. So the first thing you should be saying is this is not on the unit circle. 3x is not on the unit circle. So we've got to treat it like a triangle instead. We have an angle whose cosine is 3x. Well, that's 3x over 1. Because we can't call it an x value unless it's on the unit circle. So it must be a ratio, adjacent and hypotenuse. So you'd say, I have a right triangle. I have an angle whose cosine is adjacent over hypotenuse. Now it says find the sine of that triangle. You will have one like this on the test. 3x isn't on there anymore. But if your other sides aren't, those ratios were not on the unit circle. Not true. So let's do the math to find out this side. Guys, we gotta just roll with it. We know how to find that side. Just because there's an unknown doesn't mean that algebra is not going to be the same, correct? So let's do the true statement would be 1 squared minus both 3x squared equals the other side squared. So now we really have 1 minus 9x squared equals question mark squared, don't we? So then question mark is square root, correct. Am I right? Can I go square root that, square root that? Yes, that's breaking the most forbidden of all forbidden. Algebra genius right there. We cannot do it across a subtraction sign. Those are the things you get into trouble with in calculus. You can do algebra like this, you're good to go. So the square root of 1 minus 9x squared. Remember, it's breaking the forbidden rule to square root that over a subtraction sign, right? You can't split it up. Adam, answer me this. X minus 3 squared. Can I square that, square that? Heck no. So would it be okay to go, I'm going to 1/2 that, 1/2 that? Well, isn't that what that is? A 1/2 power? Do you see how that's breaking the forbidden rule? So you're going to, you can't do that. Once again, that would be doing 1/2 that, 1/2 that. Even if we wrote 1 minus 9x squared to the 1/2, we can't 1/2 that, 1/2 that. Okay, cool. Back to it now. Now that we answered the algebra question, so now our answer is sine is opposite over hypotenuse. So what would my answer be? Right? Opposite over hypotenuse. Good point. Now, I never thought about this till you guys brought this up. Should that have been negative? Arc cosine, we better make sure. Isn't that a triangle here or here for arc cosine? So 1, 1, 3x was positive, so we lucked out and happened to get it correct. Because this was positive 3x. Does that make sense, everybody? It's going to be a positive. So, oh yeah, and luckily on cosine up here would be positive anyway. So we're lucking out. So see how in the past, like not even thinking about those things, we've kind of lucked out. Look. Okay, let's do tangent of arc cosine of 3x. Luckily, it's not the triangle we already have. So we're asked to find the cotangent of this picture. The right triangle, theta, square root of 1 minus 9x squared, 1, and 3x. So isn't cotangent over adjacent? So cotangent of theta is adjacent over opposite. So we would say adjacent is 3x. Our opposite is the square root of 1 minus 9x squared. And then you're making a good point. Yes. So then, how would I rationalize the denominator? Okay, watching, because this is some algebra that some of you might make mistakes on. So on top we have a 3x square root of 1 minus 9x squared, don't I? Then on bottom, what do I have? 1 minus 9x squared. Oh, well look. 3x and 9x squared. Boom. Let's cancel those out. No. See? Look how good you guys are at algebra. You're going to be algebra geniuses. So that is our answer. We could not divide across a subtraction sign, right? Right? Can't divide across a subtraction sign. What if we all pretended like you guys didn't say dumb things? Ooh. Burns. Burns. 339. 349. I know I do. Thanks.